Hey everyone, welcome back to my YouTube channel. In this video, we'll be solving a Leet Code problem. Leet Code problem 5 that says you have to find the longest substring in a given string. We'll be solving this using dynamic programming, and by the end of the video, you'll realize this problem is easier than it looks. Let's jump right onto it. The problem statement is, in a given string, we have to find the longest substring, which is a palindrome. And to be able to do that, we should first know what is a palindromic string. So any string is called a palindrome if it reads the same from left and right. For example, level here, if I read it from the left the usual way, it reads level level. If I read it from the opposite direction, which is from right to left, it still reads level level. So it's a palindrome. Same is true for noon and race car. Race car is a read race car from left, and from the right also it's read race car. If to this noon I add s, it becomes noons. So when I'm reading it from left, it is noons noons. When I'm reading it from right, it is snoon snoon, and it's not the same as noons. So this is not a palindrome. Now that we know what a palindrome is, we can apply some logic to detect a palindromic substring, and we'll be using dynamic programming for that. So dynamic programming is all about optimization, and the idea is to store the result of subproblems so that instead of solving the bigger problem at once, we can use the saved result of subproblems to optimize our solution. For example, if I have to find out if these given strings are palindrome or not, let's start with B. It's a string with single character, and all the strings that are of length 1 are palindromes. So B is a palindrome. Then if I have a string ABA, now if I have to detect if ABA is a palindrome or not, I can check the boundary values, and for the inner value, if I already know if the inner string is a palindrome or not, I can just reuse that knowledge to save me some time. So I know B is a palindrome and A and A are same. That makes ABA a palindrome. So the only thing that I checked here is if boundary values are same and if the inner string is a palindrome or not. Then if we talk about XABAX, here the boundary values are x and x, so they are the same. And if I talk about string ABA, we just calculated that ABA is a palindrome. So I don't have to check for it again. And with that, I can say yes, XABAX is also a palindrome. And the knowledge of knowing ABA is a palindrome helped me in detecting whether XABAX is a palindrome or not. Similarly, if we talk about XABAY, here we know ABA is a palindrome, but X and Y are not equal, so that's why it's not a palindrome. So the idea here is that we are storing the substrings result, whether they're palindrome or not, and then we'll use these to find the result of bigger strings without calculating the substring again and again. We'll be saving the results of these subproblems in a table that we can represent with a 2D array. Now there are just 3 rules to it. First is that any string that is of length 1 is always a palindrome. So if I have to fill this table, and this table is read such that on the left I have the left index and at the top I have the right index. So if I'm reading 0 0, that means from left to right this string's 0th index. If I'm reading 1 3, that means this substring from 1 on the left to 3 on the right, OON. So strings with length 1 will always be palindrome, and I can just save that. So I'll just write 1 here. In this table, we only have to store whether the substrings are palindrome or not, and we'll just use them for the bigger substrings. So any string with length 1 is palindrome. We just populated that in the table. Similarly, if we have a string of length 2, it will be a palindrome if both the characters are same. For example, OO or AA. But if we have AB, then that's not a palindrome. So for a string of length 2 to be a palindrome, both the characters have to be same. And we can just check for that and populate that here. So if I talk about 0, 1, that's NO, it's not the same, so I'll put 0 here. If I talk about 1, 2, which is OO, they are the same, so I'll put 1 here. If I talk about 2, 3, which is ON, that's again not the same, so I'll put 0 here. And we'll only be using the space above the diagonal on this one, so we'll just ignore this space, we don't need it. Now when it comes to length greater than equals to 3, for any string of length greater than equals to 3, we can say it's a palindrome if the boundary values are the same, something similar that we checked with XABAX. So if the boundary values are the same, and if the inner substring which we'll get by moving one place ahead from left and one place behind from right. So if I'm here, this is my L, this is my right, I'll move one place ahead from left and one place behind from right, and I'll get this substring. I need to know whether that is a palindrome or not. If that's a palindrome and the boundary values are same, then the incoming string is also a palindrome. So now we can use this knowledge to fill up this table further. So if I talk about 0, 2, that is NOO. So we know O is a palindrome, but NO are not same, so this becomes 0. Similarly, if we talk about 1, 3, OON, O is a palindrome, but ONN are not same, so this becomes 0. Now we come to the last value, which is 0, 3, which is this complete string NON. We know OO, which is 1, 2, which is this value right here. This is a palindrome, and N and N are same, the boundary values, so that makes noon a palindrome. And since this is the highest value, this is the longest palindromic substring in noon. Let's use this same knowledge on this string BABAA. So again, for strings with length 1, they are palindromes. For length 2, they're palindrome if both the characters are same. So 0, 1 BA is not palindrome. 1, 2, that's AB, it's not palindrome. Then 2, 3, which is BA, is not palindrome. And then 3, 4, which is AA, that is a palindrome. So I'll just populate that as 1. We don't need this space. Now we go over to length greater than equals to 3. So we start with 0 and 2. So going from 0 to 2, we have BAB. We know A is a palindrome and B and B are the same, so that makes BAB a palindrome. If I go from 1 to 3, which is this place, we have ABA. We know B is a palindrome, which is the second, and A is same as A, so that makes this a palindrome. Then we can check for 2 to 4, which is BAA. A is a palindrome, but B and A are not equal, so this becomes 0. Now we can go for length 4, which is 0 to 3. With 0 to 3, I have B and A in boundary values, and also AB is not a palindrome, so this is definitely 0. And then from 1 to 4, we have AA, but BA is not a palindrome, so that makes it 0. Now for the final value, which is 0 to 4, which is the complete string, ABA is a palindrome, but B is not equals to A, which is the boundary values. So that makes it 0. In case if this was B, then 1 to 3 is a palindrome, and also 0 and 4, the boundary values are BB. That would have been the same, and then we can enter 1 here for BA, BAB. Now we'll use some code logic to fill up this table and then use this table to detect the longest palindromic substring. It is time we coded the solution that we just discussed, and I'm going to do it in Leet Code itself. So I am at the longest palindromic substring problem. Let's start writing the code here. The first thing that I want to do is get the length of this string. Then I'll create that 2D array for storing the table. And since it's a 2D table, I'll initialize the complete array one more time so that it becomes n cross n. And I'll set bool tables index equals to new array of, it will be strlen. Okay, now we'll start with the first step, that is to mark the strings of length 1 as palindromes in the table. To do that, we can just iterate till the length. And I'll simply set bool tables index, which is this diagonal, to 1, because all strings of length 1 are palindrome. And since we're calling it a bool table, instead of storing 1, let's simply save true or false in there. 1 for true and 0 for false. Once we're done dealing with the strings of length 1, we can do the same for strings with length 2 as palindrome based on same characters. So for length 2, if both the characters are same, then it's a palindrome. So we'll again run our same loop. And here I'll just put a check if, and instead of going to str length -1, we'll have this run only till str length, because we'll be checking if strings index is equals to strings index plus 1. That means if the adjacent characters are same. Then in the bool table, we'll set index and index plus 1 to true. Okay, this is the second step of our algorithm. And if we find a string of length 2 that is a palindrome, so we should save that. And for that, I'll create a variable here, which will be max length. I'll initialize it to 0. Also a start pointer, which will again be 0 to begin with. So once we find a match in length 2, we'll simply set the max length to 2. We can keep a static value here because we know it will always be 2, and start will simply be the index. Okay, so we have covered the scenario of length 1 and 2. Now we can code the scenario for length greater than equals to greater than equals to 3. Use the sliding window approach. For that, I'll start my index from 3, or I'll just call it the substring length. Till this is less than the string length. We'll keep incrementing it. Now for each length, I want to check the string from left and right. So I can have a variable left, and actually, since it's a sliding window, we'll keep incrementing left. So we'll put it in a loop. So left will always start from 0, and it will go till left is less than the string length minus the substring length, and then a -1 for index, and left plus plus. And right will simply be left minus the substring, left plus the substring length -1. Looks good. And now we can just check for the condition if for our bool table left and right is actually left plus 1, because we have to check for the inner substring. If bool left plus 1 and right plus 1 is true, and our strings left is equals to strings right. If this is the case, then we'll set the bool tables left and right to true, and if the length of substring is greater than the max length, that means we have found a new longest substring. We'll simply set max length equals to the substring length, and start will become left. Okay, let's try to run this. Oh, we also had to return that substring. So we'll simply use JavaScript function and call str.substring starting at left and ending at left plus max length. Starting at start, not left. Okay, let's run it. Okay, it worked for both these cases. I know one case for which it will not work, so let's try that. If we try level, it's failing for level. It did not give any output. Let's try AB level BA. So now it gave level as an output, because when we are running the length loop, instead of ending it at string length -1, we actually wanted to cover the complete string. So we will set it to string length +1. Because we are making a less than check. Had it been a less than equals to check, then we can put a string length in there, but why to put two comparisons? So we'll set it less than the string length +1. Similarly, for our left variable, it should be string length minus the substring length and +1. Let's try it. Okay, now that's working as expected. Let's submit it and see how it goes. Oh, it passed 133 out of 140 test cases. For string A, it did not output anything. Nice. So when we're initializing this and there's only just a single character, we can default its max length to be 1. Let's submit it now. Okay, that got accepted. And we have our solution. I hope that was helpful. If you have any doubts in the approach that we followed, feel free to reach out to me on LinkedIn or Instagram. And you know it, if you liked the video, please share it with your friends so they can benefit from it. Subscribe to the channel for more learning content. I'll see you in the next one. Peace.